Yeah, welcome to the community call, everybody. Super excited to have you all here today. We've got a very full episode today. So we're going to go ahead and actually just kick it off. Here is today's agenda. If you did not get the email already and you're just showing up because we're on your calendar and you're like, that's why I come. We've got streaming subscriptions covered a few times. We got some more updates there, which is going to be a really great one to have a look at. We have SQLite, which is like super exciting to see what's the status there. Best practices for observability, monitoring, and using Datadog, and then auto cleanup for event triggers, as well as then a teaser for Cockroach DB. So without any further ado, we're going to go ahead and actually just kick it off with streaming subscriptions. So Rahul, are you ready to go?
Yes, please.
All right. I'm going to stop sharing my screen and give you the floor.
Oh, just a minute. Just quick check. Are you seeing my introducing streaming?
We do.
All right. Hi, everyone. So very excited to kind of introduce streaming subscriptions. If you have not already seen the webinar or our blog post and you are seeing it for the first time, with Hasura, now you can stream data models directly to the edge to build those real-time applications, which I'm very sure you would have a real-time component in one of the applications you're building. And what we are doing is we are allowing the capability to use a GraphQL subscription over WebSocket transport protocol. All that under the hood stuff you don't need to worry about, and Hasura will do it for you. And it will enable you to fetch large amounts of data and get new data instantly possible. We can't really wait for you to try this out and unlock these new variety of use cases around large fetches and time-sensitive data. So what on the side you are looking at is the simplicity of our solution is you just need a Postgres database along with Hasura and you're ready to stream APIs onto the edge. And this is also kind of showing you a before-after picture for folks on the call who have attempted creating a streaming API. It's not the easiest thing to do in the world. You have to talk about authorization rules. You have to think about scaling WebSockets. You have to maintain cursors. You have to maintain the historical data. You have to synchronize data, all that stuff. And on top of it, you need to then think about scaling to different clients. Then only you can achieve a valid streaming use case. With Hasura, as you see on the right, it is very simplified. As you just, Hasura takes care of the scaling from a consumption point of view for your client, and just run Hasura on a container or on Hasura cloud and you're good to go. So this is what we're really excited about, to kind of give this functionality to you so they can easily go to market as soon as possible. And also, I will go through this in my demo as well, but for folks who've been using subscriptions before, you might be aware of live queries. So live queries and streaming are different in a way that live queries just give you the change of the data set whenever the change happens, and it will give you the entire data field at that time, which is not the best performant level, and it does not meet all the use cases. With streaming, we have introduced a cursor and a batch size. So a cursor can be configured based on your needs, and a batch size, which will provide data in those batch inserts. And we will, I'll show you 2 demos today on streaming real quickly, and you will see how it all comes together. And I would urge you to open a Hasura instance right now. We'll do a small 1-minute exercise together, build a stream on the spot live, and then I'll show you a sophisticated streaming use case which could be used in an application. So yeah, I should have told that before, but right now, please open your Hasura cloud or whichever Hasura instance and go to the data tab while I bring up my screen for the demo. And what I will be demoing today would be the ephemeral data use case, which is update event trigger is directly streamed using the streaming API service. So you could do an update event, or if the table is also being updated, with new entries, how to kind of capture that. And the demo which I'll be showing today would be the recently booked, which is a second use case which you are seeing here. And that's what I'm going to demo. And with that, let me set up for that. So while I'm doing that, please open the data tab so that we could do this together. Got it. So what I'm going to do right now is, I hope you're able to see my Hasura data table right now. And I'm just going to create a table, and you can come along with me here. So I'm creating a table, very simple table. I'll call it birds. And I'm putting column ID. I'm auto-incrementing it. A column name, and column type text, primary key ID, add table. So you have the table set up at your end, right? So let me insert one row here. Let me call it the first bird falcon. And if I go, I'll have this one thing. So for people who are following up along with me, I would say that you could then run this query, which I'm going to provide in the chat, and do it in front of you here as well. So I'm going to populate this table with more birds. So if I go here, I have all my birds here. And then you can then go to the API tab right now with me. So I'm going to the API tab, and I'm going to copy paste this streaming query onto the API tab and run this. So you see my table getting streamed right now on the fly. All my birds are getting streamed, as you can see right now. And then I can play around with it. I could say that let me stream with from 5. So it will start streaming from 5. Things like that. You could change the batch size. I want batch size of 4, and it will give you 4 entries again and again, things like that. So hope you were able to follow along with me and have a streaming API on a very simple table within a minute. Just to show you the difference between live query and streaming, this is the live query which you can run right now on this table. So if I go here and run live query, so you see live query then provides you all the data set. And if in the interest of time, I'm not going to do it, but if I were to add an entry right now, it would show ID 15, name that. So there's a persistent connection, but all the data set is coming together. So hope you're able to visualize the difference between live query and streaming and how powerful it's going to be for your real-time app. So with that, real quickly, I want to show you something in action. Like how would you do this if you were building an app? So created this nice looking app using a tool called locofy.ai. If you haven't used locofy.ai, we recommend for quickly going from Figma to React. But everything behind this app is coming from Hasura. So all these values which are coming from Hasura. So let me just show you the streaming aspect here. So what we want to focus here, all the metadata is coming from Hasura behind the scene. And what I want you to focus on is on the right, the recently booked section. So you have any user who has recently booked from Singapore to San Francisco, that recently booked flight will come here instantly. And now what is happening behind the scene, I'll show you the query for that. So this is the subscription or the streaming query for that recently booked section, which I showed on the app. And if I were to run this streaming query, as you see that all my recently booked flights are coming as they are being booked on the right. And if I were to kind of show you this thing in real time, so let me bring the SQLite app here. So you're seeing that the last value is 6,000. Let me insert a value on the fly, and it should move on the recently boot as I enter the value. So let me insert again. So you see the value changed. Let's say if I were to go here and quickly change to another flight code and change the value to 5,000 and then save it. So you see that the recently boot has changed from American Airlines $6,000 to Emirates $5,000. So hopefully this gives you a kind of an end-to-end picture of what streaming subscription is all about. We here at Hasura are super excited about this, and we would really want you to try this out. Let us know if any feedback or pain points while adopting the feature set. And with this, I have one more thing to share very quickly, and then I'll hand it over to the next speaker, which is a chat or streaming messaging is something which you can also do with this feature set. What you're looking at here is an architecture diagram or use case diagram for a chat app. And then I highly recommend you to check out this GitHub repository and start building a chat app currently within minutes, I would say. So I'll copy paste the link of this this GitHub repo right now for you to start building your chat app. And with that, I'm handing over to Lyndon for SQLite. So thank you.
Hi, that was awesome, Raul. Yeah, hi everyone. I'm Lyndon. I'm the dev lead for the Data Connectors project. So hopefully you've heard a little bit about Data Connectors at Hasura and in recent kind of announcements. But I'll give a tiny bit of background on that before I dive into the SQLite stuff. So for those who don't know, traditionally, Hasura has had some built-in databases that it supports. And that obviously has been like very seamless and excellent, but we would like to extend which databases we support and support a whole lot more. So what we've done is we've introduced a new way of connecting to databases through what we call data connectors, which is essentially kind of like a microservice architecture for database drivers. So that has been in the works this year, and we've been rolling out support for it somewhat semi-stealthily, so that you should be able to use that functionality with Hasura GraphQL engine. But we've also been working on some actual agents to support some new databases using the new protocol. Oh, and by the way, I just wanted to say I'm covering for Adron, who's having some internet issues today, so I'm not super prepared. So please forgive me if I'm rambling a little bit. But yeah, so we've got this new protocol, which we call data connectors, and we've got some new databases which are using that. And so we have a reference agent, which is just provided in the SDK for agent authors. But now we wanted a more practical reference agent. So we've done one for SQLite. Hopefully everyone's heard of SQLite, but if you haven't, it's a very popular file-based, lightweight, fully featured database. It's used for all kinds of interesting purposes, especially kind of like embedded reasons. But traditionally, it's not something that is super easy to access without kind of building a front end through traditional kind of application developments, you know, like your Rails or Node servers or things like that, and using an ORM or direct SQL queries. Wouldn't it be nice to just connect it up to Hasura and get a great GraphQL API through the same way that you like to consume GraphQL for everything else, which is obviously Hasura, right? So yeah, what I thought I'd do is I'll run you through a little bit about the architecture, the agent itself, the repository that we've made available, and then you know, show a couple of queries and things, and then tell you what's coming next. Yeah, so just, I don't know if you can see behind me, the light is a little bit glary, but the architecture is fairly simple, right? So if you can see this, so if you're a user using Hasura, then Hasura, rather than talking directly to a database, will be talking to an agent. In this case of the SQLite, it's a TypeScript service that uses an SQLite library to use a local SQLite database file, right? So the only real difference from what you've traditionally seen is you would have seen an arrow going here, but now you bounce through an agent instead. So if you were to spin up the infrastructure for this, you would need to run an agent in proximity to the database file. And then once you've done that, you can connect it up to Hasura to expose that through the normal kind of processes. So yeah, I'll jump over to the repository and quickly show you that. So yeah, we've made this public. It's still a work in progress, but you can check it out. It's GitHub Hasura SQLite Data Connector Agent, and you'll see this is a TypeScript project, and we've kind of listed out how you can build and run this. It's all kind of Dockerized if you want to do it that way, or you can run it with Node if you want to do it that way instead. And there's a whole bunch of kind of environment variables that you can use to configure it. You can set up the obvious stuff like the port. You can also set up some more advanced things like whether it's permits CORS requests, which database files it allows, read-only mode, whether it kind of pretty prints the logs, all sorts of things like that, exposing Prometheus metrics as well, which is quite interesting. But yeah, so that's kind of the overview. Inside I'll dive into a little bit of the code soon, so you can see what that's like. But I'll just show you a quick query first. So it's actually a very fully functioned kind of read-only layer at the moment. So pretty much all the queries you would have been used to from GraphQL engine connecting to something like Postgres, you can do on SQLite. So it's quite impressive what you can leverage here. Basically, pretty much anything that you would want to do as a read-only query, you can do. So yeah. So what I would say actually is, how did we achieve this? So we did it pretty much in a similar way to our native Postgres implementation, in that we generate SQL. So pretty much the entire query is compiled to an SQL expression and executed in SQLite. So SQLite's support for aggregation functions makes that very easy and very natural. Not to dismiss the work that went into it, but yeah, at least it's possible, and you can have it use the SQLite's query optimizer to kind of make that efficient, and it actually works very well. And you can get a whole bunch of functionality fairly easily from that side of things. We also use the data connectors kind of API protocol, and we generate all of the types that protocol requires and publish them on NPM. So if you also want to make a TypeScript based data connector agent, then you can use this package to make sure that you're supporting the protocol. It's also
real quick.
Yeah.
Are you sharing your screen?
Oh, are you not seeing my screen?
We're not seeing your screen.
Oh, okay. I thought I shared it. I'll try again. There we go. How's that?
There we go. Yep, perfect. Thank you.
Thanks. Yeah, hopefully most of that made sense without seeing the screen. Yeah, I'll show you the query again, because that's one of the interesting things, right? So yeah, this is what a query would look like. Hopefully that's not too surprising. You would see something like this. So we're using the Chinook database as an example here, and you can kind of do the usual things you would see in a Postgres query, but in SQLite. Then I just jumped over to this npm package here, Hasura DC API types. So if you are interested in actually building your own TypeScript-based data connector agent, like we did for SQLite, you can check out this package. If you want to see the code, the agent is available here, and we should also be publishing Docker images of that as well. If you just want to run the agent to serve up your SQLite database files. So how are we going for time? Yeah. So then, so how do you actually configure this? So we're still kind of building up a fair bit of the console functionality at the moment, but we do support using the metadata API for loading in these. So our data connectors support currently, if you want to manually connect to a data connector, you would use what we call this backend config section, and you would specify the kind of name of the implementation, and then the location of the agent. So I'm running my agent here on localhost on port 8100, the default port, and that's running the node server that receives the data connector protocol requests, and this one will then allow you to add sources named after this. So in this case, sorry, actually this one is the reference agent. So I'll jump back over to here. And if we export the metadata. Yeah, so in this case, here we go. That makes a bit more sense, hopefully. This case, you would be able to see the configuration that's associated with it, specifying a test database file, which is this Chinook file here. So that's why we see the artists and albums and things like that. So these are kind of like the two main blocks that you might not be familiar with traditional Hasura configuration. But besides that, the entire rest of this block looks like a normal source. You can have normal tables and things you can do with that. Like I said, this is currently only read-only. So quickly jumping back to HGE, if you see me execute a request again, so if we go back to API, then you should see that coming through here. So if I can format this so you can see it a little bit more nicely. Sorry, the Zoom stuff is getting in the way. There we go. So the actual SQL that would get generated against your SQLite database would look something like this. So yeah, we're definitely leveraging the kind of JSON capabilities and the aggregation functions to make that possible. Yeah, so then I might quickly tell you what's coming up next. So yeah, right now this is still very useful. But coming up next, we're going to make the console integration much more seamless. So everything should behave very much like any other native feature in SQLite, provided you've got the data connector agent running on the network. We'll also obviously be rolling out mutations support sometime in the near future. And also we're intending to package this up as another reference agent inside the SDK. For people who want to author their own agents and use a more SQL-oriented reference agent. One other exciting thing that's coming up in the future is what we're calling the data loader. That should make the implementation quite a bit more terse in some circumstances. But yeah, I guess that's it. I can stop for any questions or anything that people want to ask, or if we're out of time, move on to the next person. Yeah, what are the feels?
I think we'll keep moving along with the next talk, but definitely there's already some questions in chat. So we'll let you go ahead and answer those real time in the chat there. Fantastic demo. This stuff is super exciting. So really appreciate that pinch hit demo as well. So really appreciate you hopping in there and giving us the rundown. So thanks for that.
Cheers.
Coming up next, we have Raju, and Raju will be giving us the presentation on best practices for observability and monitoring using Datadog. You ready, Raju?
Yes, sir. Can you guys see my screen? Is it loud and clear? Is it visible?
We can see it. Nice and clear.
Thank you. So we're going to talk about observability. What does that mean? A system is meant to be observable if you can examine its output and measure the internal state of that system, right? So a lot of the times when you are building your own system or you are using some kind of open source code, you have complete observability into the inner workings of the system because you have access to all of the tooling and instrumentation and everything. But this is for systems where you have limited visibility into that proverbial box. That's where observability comes into the picture. So that observability allows you to gain insights into the functionality of the system. We can use distributed tracing. We'll cover all of these in detail. And it lets you audit and debug any issues that you might have. If it allows you to analyze the system at scale, not just one issue or one query or one request. It lets you analyze the entire system at scale. So with observability, there are 3 pillars of observability. That's logs, metrics, and traces. A combination of all 3 gives you a complete visibility and understanding of your system, even though you don't have a full access into the inner workings of the system. When you follow the standards for instrumenting logs, metrics, and traces, you create an observable system. Going deeper into logs, this would be the easiest to generate and instrument. Most of the application frameworks, libraries, languages, they all come with support for logging. Pretty much every component of a distributed system will generate logs. In terms of Hasura, you can actually go on this link and you can actually see how to access logs depending on which mode of deployment you have chosen to deploy Hasura. Is it on self-hosted? Is it on a cloud service? It all varies depending on that. You can actually see which all the log types and everything in here. So give it a look. And you can set your log levels using the environment variable Hasura GraphQL log level. Coming to metrics, metrics are numerical representation of data that can be used to determine a service's behavior over the time. So think about it like a name value pair with a timestamp being generated continuously as a time series. Right? That conveys information about your SLAs, SLOs, all of those things. So how do you configure metrics for Hasura? Again, there's an environment variable. Prometheus metrics are enabled by default. You can use the environment variable GraphQL enabled APIs in that format, and you have your metrics exported now. And it's always good to protect your metrics endpoint with a secret. Just like with logs, you have the entire list of exported metrics available in the documentation. There's more being added every quarter. Then it comes to tracing. Logs and metrics are enough to or adequate to understand an individual system's behavior or performance. The problem with that is systems are no longer individual or monoliths. Systems are complicated, systems are distributed, systems have components where your data goes into, comes out. So logs or metrics rarely provide any kind of helpful information in understanding the lifetime of a request that it spends inside your entire system. Right? So traces would provide context for other components of observability, let's say. So for instance, you can analyze a trace to identify the most valuable metrics based on what you're trying to accomplish. Right? So traces will help you understand the overall system health, whether there are bottlenecks, where there is a component in the system where you're getting where your request is spending way too much time than it is supposed to be. If there is a inefficient component where it is not processed fast enough. So you identify what services in your systems are inefficient or problematic, and then you go into the individual service health and performance. You can measure the individual service and health performance of your the whole system. And finally, you basically, once you identify all of those what do you call slow moving components and optimize them, you increase the performance of your overall system and make it a better UI experience. Now, this is for a system. This is for your application, or in terms of Hasura, database is also a big part. Database plays a big part in this because we are providing APIs for your data. So DB observability is vital. It lets you gain insight into your database. It lets you monitor query performance. It gives you reports on multiple host level metrics like CPU usage, memory, and with query tags, you can actually with query tags you can. I assume everybody knows what a query tag is. It's basically name value pairs embedded into comments. It lets you give more visibility into the query workload by you can filter by a tag and seeing only the query families where an execution had that specified tag. So you're getting a fine-grained visibility into the queries that is being executed into your database. Now, observability comes by default in Hasura. You have your golden metrics provided in the monitoring tab of your console, but you need an APM integration for your choice. Why? Because when you build a system, it's not just going to be Hasura that is going to be part of your system. Hasura will be one component of your system. You might have a database that you have hosted elsewhere. You might have another application components. You might have other parts of your system which runs business logic or anything like that. What we have done is we have provided a best practices guide for how to set up observability here. This is in the main document page under the guides and tutorials section. It gives you a better explanation of what we have just covered quickly here. This is constantly getting updated. We are adding more information about more integrations, things like that. So what we'll cover now is how to troubleshoot an example where there is a performance bottleneck using the tools available within Hasura and outside Hasura. And then finally, we will give you I'll give you a sample of a Datadog dashboard that we have built that covers not only just Hasura, your DB host, and every other component involved in this. This is your console's golden metrics that, as you can see, you have the request rate, you have the errors, execution time, all of those things are here. But that is strictly limited to Hasura and the Hasura part of your system. That's not what you want ideally, right? So that is why we ask that you invest time and effort into building and integrating your systems with a third-party API. So what we are doing here is based on this demo is going to take a lot of time in real time. So I'm going to use the magic of screenshots. As you can see, I'm running this query and it takes about 5.8 seconds to execute, completely finish. So I need to find out what is wrong with it. So I can use Hasura's built-in tools like the analyzer part, and using the generate less SQL and execution plan. I see that there is a sequential scan happening on the tracks, which is going to cost me. So using a query plan and analyzer, I can actually see that this is where I spent most of the time on that sequential scan on the tracks field. So what I understand is that looking at it, I can add an index on that. I can add an index on that tracks field, and once I add that index, it brings the full query execution time to less than half a millisecond, 250 millisecond, approximately 250 milliseconds. And if I go further deep down into this, what was once 245,000 as a cost is now 43,500. So this is what observability helps you do. It lets you analyze inefficient components in your system. It lets you fix those performance bottlenecks and make sure that the users have a better experience when they interact with your system. Now, coming to third-party platforms. Obviously, like I said, Hasura is not going to be the only component that you're going to have to monitor when you deploy a big system. So Hasura has multiple integrations with multiple common observability platform. You can actually see the list of supported platforms here: Datadog, New Relic, Azure Monitor, Prometheus, and we are fully open telemetry compliant. And if you drill deeper into this, you can actually find out how to configure that integration and how to get things going. Coming back to it, the other aspect is integration with an IRP system, incident reporting and propagation. So what if there is an outage? Sure, your Datadog or your APM has enough tools to alert you via an email or send you a notification if you have an application installed. But to do that organization-wide, to do that, let's say I'm supposed to be alerted, but I'm in a place where I have no data. IRP platforms allow you to reach out to you in multiple places. It could be a text message, it could be a phone call, whatever it is, you can configure that. So it is highly recommended that you integrate your observability platform with an IRP system. We at Hasura, we actually use hold on just one second, PagerDuty as an IRP system for our support tickets. Now let me walk you through a dashboard that we have built for system-wide observability here. So as you can see, this is just one second. Let it refresh. Yeah. So as you can see, this is a standalone performance data dashboard that we built on Datadog. It gives you one quick, a single pane of glass sort of view into everything that you need to see. You can actually see all the golden metrics here and the monitoring summary. You have one alert where my request per minute is going under 99% success. I am monitoring my GraphQL endpoint. I am monitoring my database host status. I am actually monitoring the database status itself. These are pretty near-time alerts. I get emails whenever something happens in this, but again, if you need it to be perfectly real-time, it is better to integrate with an IRP system. Going down, I have the CPU memory usage for my database system. I have the success rate represented as a time series here. I can one means it is 100% successful. And if I go further down, I have configured it to give me further information on the database host that I'm using. One is connected, one is hosted on DigitalOcean, and one is hosted locally inside my network, the replica. It gives you a fair amount of details here. It gives you the number of rows that are being fetched or inserted or updated per second, how many current connections exist, and to which individual databases are the current connections established to. Then I have a separate graph for any write operations that is happening in there. Then coming to the system parameters, I have my IO weight, I have my uptime here, I have a time series of my CPU usage graph, memory usage, and one critical component that people often forget is NTP. I advise it is a good practice to actually monitor NTP and make sure that the offset doesn't go above your organization's allowed values. And then there's network traffic, real-time network traffic that is being monitored. All the processes that are currently using any kind of memory, significant memory, are being mapped here. And then finally, I have a graph that tells you which maximum number of connections that are being connected to the database itself. So which applications are connecting, how many number of connections are they using, and which database are they connecting to. All of those finer details will let you debug the system in much better efficiency. Now, if you go into the APM tab, I can actually see a better view of my database monitoring. I've configured this to give me the list of most frequently executed queries, how much latency am I looking at, what is the total time spent per execution, so you just multiply these and you know how much time the system is spent per day or in the past 1 hour processing that single query. So this helps you plan your, debug further into your queries. And like I showed in that example, you can easily find out if there is an inefficient query, which can be fixed by adding an index, things like that. So this dashboard and the database monitoring guide will be added to the best practices / observability link within a day. You will be providing sample JSON files for this dashboard so that you guys don't need to go and hunt around for or try to create these dashboards. You can straight up import that JSON into your Datadog dashboard, and you're all set. This has been observability. I will now pass it to the next presenter. That is I don't know. Rahul.
And thank you, Raju, for the really great demo. And also the JSON dump will be super, super helpful for people to just get up and running, because that is a lot of fiddling around. So
yes, it took us a while to get here, but we're here now. We're happy to share the files.
Very good. All right, Rahul, are you ready to show us auto cleanup for old trigger events?
Yes, ready. Thank you, Raju, for that. Great stuff. Are you able to see my slides?
Yes, we can.
All right. So a brief introduction before I go into the demo. So what are we releasing? It's not released yet. It's in 2.13 version, so coming in a week or so. So have a look out for that. And you will be able to perform high event triggers with zero administration. That is our promise to you. So as I mentioned, it's a new paid feature, and it will give you the ability to automate the cleanup of event trigger logs and invocation logs based on some configurable parameters, which you see on the right, such as clear logs after this time, or what should be the frequency of cleaning up, some advanced settings like timeout of cleanup and the batch size of cleanup, so that during cleanup, your database doesn't go down. So all those things have been kind of taken into consideration, and I will show you where to set this in my demo. Why is it important? Because many customers, I don't know if you are on the call, but we have heard this from many customers using event trigger, that because of a high load, the system just becomes slow and at a point where I can't even use it. And for me to kind of clean the logs in a manual process takes a lot of time. I have to synchronously watch that cleanup happening and then debug issues. It's a lot of mess to kind of clean up the mess which the system created, and that kind of prevents you to be confident with high performant use cases which you want to execute. So as I mentioned, it would help you with performance and reliability issues in this high event load scenarios. And what I will demo today would be console, but there is flexibility of configuration, because we understand that for customers who really have these high load use cases, you need flexibility of configuration. So you could do it via changing the that table name which I've mentioned there and import the metadata on the CLI aspect, and then you could also do it with the metadata API by interacting with the create event trigger endpoint. There is also a manual. I will not go into the demo today about a particular configurable parameter called paused. You could look up that thing in the documentation, but what that enables you to do is do manual API as well using automatic cleaners. So these are the three ways apart from the console where you could clean up your event logs. So with that, let me quickly share my screen to the console and show you this in action. Just a quick check, you were able to see my console?
Yes.
All right, thank you. So what I did here was I just created a demo table and I created a insert event trigger on that. So let me show you the table first. It's a pretty simple table, kind of mimicking a real world use case where you maybe have an event trigger on a logged user table and you want to get notification or some kind of action whenever a new user gets logged in, and would that be an entry in that table? So here you have a logged in users table with simple ID and name. And then if you go to the event tab, I created a demo event trigger, which is just an insert trigger on this table. Pretty simple in that way. And as you can see, I process certain events behind the scene. So it has around 100 events or so. And we can actually see how many events are there and invocation logs are there, so that in the demo, we see that number go down. So what I'm going to do is just run this SQL on the HDB catalog.event log and HDB catalog.event invocation logs to see how many logs do we have currently. So if I run this query, so we have 133 event logs and 133 invocation logs. So let's keep that number in mind because that number needs to go down for the demo to be successful. So let's go to the event trigger tab. And while you're creating the event trigger or modifying the event trigger, the auto cleanup event log settings will come here. And one nuance with the setting is that, as you can see, the invocation logs is a little grayed out. You cannot just clear invocation logs. There are two options available to you, either only event logs or event log and invocation logs. So for now, we're going to select both event log cleanup and invocation log cleanup. Clear logs older than ours, so for demo purposes, I'm using 0 as a value, but realistically, it would be like a day or 12 hours, things like that. Cleanup frequencies, I would say there are different frequencies, and this is where the ease of use zero administration point really comes into play, because all you need to do is, I want it every month start, or every midnight, or every Friday night, or every 10 minutes. And that is where the flexibility you can get for this automated cleanup. For demo purpose, obviously, I will use the every minute option, unless we want to stay here for a while. And then the advanced settings are more on the performance level, so that if, let's say, you have millions of event triggers and you run the cleanup, and the cleanup process brings your database down. So not a good thing, right? So we have these protective measures in that case, the timeout and the batch size, which make sure that the cleanup is also happening in a performant way. So with that, I think we have all the settings in place. So we were at 133, and if the batch size is 5, it should go down to 128, and in that increments. So let me save the event trigger. So we have the auto cleanup on the event log working right now. And since it is every minute, so we'll give it some time to rerun this query so that the number goes down. So let me keep refreshing it in the meanwhile. And while this is happening, if I have any questions, I'll monitor the chat for anything. Just a minute. No, we don't have any questions, but if you have any questions on this, this is a good time for bring those questions up, because as you see, the logs have been reduced by 5 to 128 here. And if I run this again, it would keep decreasing in those 5 batch intervals. So hope you're able to see this number here, 128. This is what we were trying to achieve. And one last thing is that there is also good visibility via the HTTP event log cleanup table, where what you can do is just see how the cleanups are happening. So if you run this query on this table, then it will give you all the cleanup entries for you to kind of see how the cleanup happened, just like this here. And if I were to show you the cleanup which happened, yeah, so here you will see that which cleanup was completed, how many event logs were deleted, so forth and so on. So yeah, that was auto cleanup in action. Hope that really eases your problem if you're on the call or listening to the call, or new customers who are willing to go the limits with event triggers. This is going to be really useful to you. So thank you for your time. I'll hand over to the next one, please. Thank you.
Thanks, Rahul. That was a great demo, and actually one that I have run into personally as DevRel, be using free tiers of databases for my entire career here at Hasura. Getting a fold up event log is definitely something that I've struggled with and have seen some others as well. So I really appreciate that. And that's a really great feature that just removing that layer of administration is really fantastic. So thank you so much. That brings us to our last demo of the day, and that is from David Mullaney, and we have a Cockroach DB teaser. David, you ready?
Yeah, so am I muted?
Nope, we got you. We
All
can
right, cool.
see you and we can hear you and see your screen.
Cool. So we're pleased to announce that we've been working closely with Cockroach DB. They announced at Roach Fest last week that we're planning to release support for them as a native database in late October. We'll be releasing query support. There'll be a beta tag at first as we release these features, but we'll be first releasing query support and relations, and then mutations and subscriptions as well. For those of you who aren't familiar with Cockroach DB, it's one of the most popular distributed SQL databases on the marketplace. It's popular because it's cloud agnostic. Google has Spanner, and AWS has one, but people kind of enjoy it because it's cloud agnostic. There's an open source solution and a managed solution, and they have a lot of differentiating features that are specific to distributed databases. Why would you use a distributed database? If you have a requirement for your data infrastructure to achieve like global high availability, you have users or points of contact or points of presence that you want in Europe, India, Asia, and the United States, all over the world, and you want them to be just as performant as the people in the United States or your primary region, a distributed database is a solution that you should consider. Trying to build those things on your own, it's incredibly resource intensive. And so the benefits of us combining with Cockroach DB is just time to value. Building your own proprietary distributed database used to be reserved only for huge enterprises with hundreds or thousands of developers and years of development. And now with these solutions as a service that both Cockroach DB and Hasura provides to their users, you have the ability of, regardless of the size of your organization or the timelines that you're considering, you can build these solutions that were really once reserved for huge companies with years or decades of development. So it's a really cool time to kind of have all this access to projects, and you can use Cockroach DB's open source solution and run it locally and see how it works. Yeah, so we encourage you to sign up. We have, I'll share a link in the chat where you can sign up to receive more information about the beta release. At this time, I'm not going to show a demo because we just have basic query support and kind of Cockroach DB kind of up and running at this point. So there'll be more information released over time. And if you sign up for updates, we'll make sure that you get early access to any information we have.
Fantastic. I mean, can't stress enough exactly how much of a time saver that is going to be. I mean, you take the power of Hasura giving you those instant APIs, and then you add something like just globally distributed databases, like just sprinkled on top, is kind of a crazy productivity win for teams. So really appreciate all the work that's been going on to that from both the teams. And if you do have any questions, sign up like was mentioned. I'm going to go ahead and start to do our wrap up here. Let me just go ahead and share my screen real quick with a few of our community updates. Again, thank you for all the presenters we had today. A lot of great demos, just a lot of exciting things, especially on the data space here at Hasura. The last couple of things I mentioned. So we have our ongoing data and API series. If you actually are really into databases and all kinds of like nerdy details about that, we do have our YouTube series, the Data and API Show. Last episode was on Postgres on Kubernetes, which is like deliciously nerdy. So if you want to see more about that, you can find that on YouTube. We have Microsoft SQL Server coming up soon, and as well as some more BigQuery in depth. So a lot of great content coming there. We also have our Hangout with Hasura at GraphQL Summit. So if you are in the region for GraphQL Summit, which is in San Diego. Yeah, San Diego. We will be having a hangout session. So we got a place booked out where we're going to be able to just allow for some, side banter and chats and one-on-one kind of demos. So big GraphQL party happening in San Diego. So if you're in the area, sign up, let us know. We'd love to see you and just come talk about GraphQL data and everything else that our community loves so much. The next piece I'd like to mention is that we have the Enterprise GraphQL Conference on November 10th. That is a really great place to see what is the current best practices and trends for GraphQL in the enterprise, Hasura or not. I mean, of course, if you're enterprise, you're using Hasura because we are just the best ones. But that being said, it is a great space to hear all about GraphQL being adopted by companies of all sizes and figuring out what are the challenges that they were facing embracing GraphQL. And it's a great place to learn, a great place to share. And we would love to see you attend that. And then we have the Hasura Hugs, which I think are just fantastic. Hasura user groups. These are happening literally from Brazil to Tokyo and all kinds of places in between. We really are just having a lot of fun with this new startup initiative where if you would like to get a Hasura user group happening in your area, let us know, sign up. We'll sponsor the first one. And it's just a great place to come and talk about Hasura. And the resounding feedback we've heard over and over was just that people were like, it's just so nice to be able to talk about this niche technology that everybody feels kind of like it's their little secret project, but actually there's a whole bunch of us out there. So it's a great time to hang out, great time to just talk about how you're building with Hasura and a lot of fun pieces around that. And then that will bring us to our next community call happening end of October. Again, they're every Thursday end of the month. Now, October 27th is the next call. And then we have obviously Discord. If you want to keep the party going throughout the week, you can let us know any questions or just come to hang out on our Discord channel. We have people there all day long. And if you have any feedback about this show or any questions, concerns, please let us know because it is a community thing. And we want everybody to feel safe. We want everybody to feel welcome and also heard. So if you have things that you'd like to share, let us know. So that will take it up for today's community call. We appreciate y'all being here and have a great rest of your day, wherever you may be. And we'll see you next time.